Assalamualaikum everyone. In this video, I am going to cover some topics from chapter 1 of book D1. The chapter is called Prime Numbers, Highest Common Factor and Least Common Multiple. Let's start with the basics. First of all, I am going to tell you about numbers. Whole numbers are the numbers 0, 1, 2, 3, 4 and so on. They start from 0 and include every single positive number that doesn't involve fractions or decimals. Square numbers are the squares of whole numbers. They are also called perfect squares, such as 0, 1, 4, 9, 16, 25. You can get the square number by multiplying a number by itself. 0 multiplied by 0 is 0. 1 multiplied by 1 is 1. 2 multiplied by 2 is 4. 3 multiplied by 3 is 9. 4 multiplied by 4 is 16. 5 multiplied by 5 is 25 and so on and so forth. Cube numbers are the cubes of whole numbers. They are also called perfect cubes, such as 0, 1, 8, 27, 64, 125. You get the cube numbers by multiplying a number by itself 3 times. 0 into 0 into 0 is 0. 1 into 1 into 1 is 1. 2 into 2 into 2 is 8. 3 into 3 into 3 is 27. 4 into 4 into 4 is 64. 5 into 5 into 5 is 125 and so on so forth. Even numbers are the whole numbers exactly divisible by 2. They end in 0, 2, 4, 6 or 8. Odd numbers are the whole numbers not divisible by 2. They end in 1, 3, 5, 7 or 9. Here I would like to tell you some properties of even and odd numbers. While adding or subtracting them, remember that when you add or subtract two even numbers, you will get an even number. When you add or subtract two odd numbers, you will get an even number. When you add or subtract an even and an odd number, you will get an odd number. While multiplying them, remember that an even number into an even number is an even number. An odd number into an odd number is an odd number. An even number into an odd number is an even number. Now that we have learned about different numbers, let's solve some questions from exercise 1A. The question given here says that we need to estimate the value of under root 66 and cube root 218. Here we will take the help of square numbers and cube numbers. To solve under root 66, we need to think of a square number closest to 66. As you can see from the list of the square numbers that I have added here for your help, that 66 is closest to the square number 64. Therefore, the estimated value should be under root 64. Now let me explain it to you that to find the square root of a number, you want to find some number that when multiplied by itself gives you the original number. Therefore, the square root of 64 should be 8 because 8 multiplied by itself gives you 64. Likewise, we can solve cube root of 218. As the cube root of 218 is closest to 216, therefore we have written here that the estimated value is cube root 216. Now let me explain it to you that to find the cube root of a number, you want to find some number that when multiplied by itself 3 times gives you the original number. Therefore, the cube root of 216 should be 6. Because 6 multiplied by itself 3 times gives you 216. Moving on, we have prime numbers. Prime numbers are the whole numbers which have only 2 factors, 1 and itself, such as 2, 3, 5, 7, 11, 13 and so on so forth. Take the example of 2. 2 has only 2 factors, 1 and itself. Therefore, it is a prime number. Composite numbers are the whole numbers which have more than 2 factors. They are divisible by more than 2 numbers, such as 4, 6, 8, 9, 10, 12, and so on so forth. Take the example of 4. 4 has 3 factors, 1, 2, and itself. Therefore, it is a composite number. Now let us discuss some fun facts about prime and composite numbers. It would be interesting to know that except for 0 and 1, every number is either a prime or a composite number. The only even prime number is 2. All other even prime numbers can be divided by 2. No prime number greater than 5 ends in a 5. Any number greater than 5 that ends in a 5 can be divided by 5. Now let us discuss the special case of 1. The question arises that is 1 a prime number or a composite number? The number 1 is neither a prime number nor a composite number because it has only one factor, not two different factors. Here is a chart that shows prime numbers up to 100. Here the prime numbers are marked in red. This chart will help you remember the prime numbers. Now here is a chart that shows composite numbers up to 100. They are marked in red. This chart will help you remember the composite numbers. Now let us learn how to determine whether a number is a prime number or a composite number. We can do so by performing simple divisibility tests. We do the test for the first 3 prime numbers, and for the prime numbers more than 5 we can use a calculator. Well, if the given number is not divisible by any prime number less than itself, then it is a prime number. Otherwise, it is a composite number. Whenever we are given a question in which we need to determine whether a number is a prime number or a composite number, first of all, we will check if the number that is given is divisible by 2 or not. That is quite simple. If the given number is even, that is, it ends in 0, 2, 4, 6 or 8, then it is divisible by 2. If the number is divisible by 2, then it is a composite number. If it is not, then we will move on to check if the number is divisible by the next prime number, that is 3, for which we will find the sum of the digits of the given number. If the sum of the digits of the given number is divisible by 3, then the number is also divisible by 3. And if the number is divisible by 3, then it is a composite number. If it is not, then we will move on to check if the number is divisible by the next prime number, that is 5. If the given number ends in 0 or 5, then it is divisible by 5, otherwise not. If the number is divisible by 5, then it is a composite number. If it is not, then as explained earlier, we will use a calculator to find if the number is divisible by prime numbers more than 5. Now let us solve a question to apply what we have learned. Here is a question from exercise 1A in which we need to determine whether 87 is a prime number or a composite number. First of all, we will check if 87 is divisible by 2 or not. As we can see that 87 is an odd number, therefore it is not divisible by 2. As 87 is not divisible by 2, we will move on to the next divisibility test. That is to check if the number is divisible by 3 or not. To check if 87 is divisible by 3 or not, we will take the sum of the digits. The sum of the digits 8 plus 7 is 15. As 15 is divisible by 3, therefore 87 is also divisible by 3. As 87 is divisible by 3, it means that it is a composite number. In the second question, we will follow the same procedure. First of all, we will check if 73 is divisible by 2 or not. As 73 is an odd number, therefore it is not divisible by 2. Now we will move on to the next divisibility test and we will check if 73 is divisible by 3 or not. As the sum of digits 7 plus 3, that is 10, is not divisible by 3, therefore 73 is also not divisible by 3. As 73 is not divisible by 3, moving on, we will apply the next divisibility test. That is, we will check if 73 is divisible by 5 or not. Since the last digit is not 0 or 5, therefore 73 is not divisible by 5. For prime numbers greater than 5, we can use a calculator. Since 73 is not divisible by prime numbers more than 5 and less than itself, therefore 73 is a prime number. I hope that you found this video useful. Subscribe for more videos.